Okay, audio check. 1, 2, 3. Sounds okay to me, so I think we're good to get going. Let me line up a couple of things here and get ready to go. All right, ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. Today, we're developing a game with no game engine and minimal dependencies. And last time we added, and we basically took care of all my last nits, my last little complaints about different transitions and sounds. They're all done, they're all fixed. I think we're done unless we find new bugs. We do have a couple other bugs to deal with, but I don't feel like dealing with those today. Yesterday we started adding doodads, basically small decorative bits that don't affect gameplay at all. And they will, some of them will be interactive, some of them won't. Yesterday we added a simple paper airplane that flies across the room. Not interactable, not anything, just a way to fill empty space potentially. So yeah, we're gonna finish up the airplane. It's mostly there. It's not far off being done. We do want to fly left to right and right to left. We do want to move it up and down the scene a bit where it's flying, then pull it out of GameScene. That's basically the plan. Then we'll look at another one or two. That one was fairly straightforward. I want to play with a chalkboard drawing. Maybe we'll... Maybe we'll do the ball next. That will not involve any fancy art that I can't just do, because the ball itself will be very simple. Yeah, we'll see how far we get. Writing your own mini physics is plenty of work, so we'll see where we get to. Yeah, then we have two bugs. One of them is about how we cheat, so it's actually less important. Then we have a replay bug. It won't exit, doesn't work correctly. But yeah. I had a thought for the Christmas replace paper airplane with Santa's sleigh. We wouldn't even have to write any new code. We just need literally a different image. Halloween. Replace paper airplane with a witch on a broom. Could be fun. Maybe we just put some Halloween holiday ideas here. And these are all optional, so we can stop anytime. Just thinking ahead. Halloween, a pumpkin would be cool. Oh, jack-o'-lantern. Oh, here we are. We already talked about this one. Okay. And actually, okay. For St. Valentine's Day, replace paper airplane. With Cupid? He flies, right? If we did a sprite animation, it could be a very simple one. Very, very simple sprite animation. Maybe something. Just the wings flap, nothing else moves. It's only on the screen for a second, so it doesn't need a lot. So I'm just trying to spitball a bunch of ideas here. Okay. All right. So we're gonna finish up the airplane. Hey JTL, how's it going? Let me know if you think of any cool doodads to add. I'm happy to consider anything. My only considerations at this point are how much more art and custom code will they require. Loading bubbles. So these would be chalk drawings of a bubble bound to the ChalkBoard area, so they'd be floating off the walls. Just different ideas. Random ideas. For science, solar system, drawing that rotates and things, that could be fun. Doing good today, finishing a presentation for work, then planning to work on your art. Oh, cool. Well, that could be fun. All right, so let's go finish up the airplane. Maybe we move the airplane out. Doodad airplane. We need that. We're gonna need a texture quad. We're gonna need an egg timer. That's probably most of what we need. I guess the image warehouse. We will need CMath. Okay. It needs an update and a render. You know we need those things. Render, I believe, takes these. We aren't going to allow clicking on the airplane, so that doesn't matter. There, that's the basic frame. That's what we're going to need today. Doing art. You know, one of these days I should just force myself to schedule like an hour a day or half an hour a day to practice drawing or something. I I have so many ideas and not enough art skill to ever execute any of them. If I start doing art, that speeds up the time to attaining, basic competencies. Okay, so Doodad airplane. GameScene, we're going to steal what we need to. Hey, look. There we go. Airplane. This is just our quad, our launch timer, launch command. That's basically it. Okay. I only need one child, so that's fine. Now I need to find everything that says airplane. Oh, let's see here. Let's steal those other functions out. Okay, in the game scene. Update. Update is simple. There's our render, easy peasy. And only initialization. We can place it anywhere, it doesn't matter. We're just porting things outside of game scene so that we declutter. There's all our initialization. No problems there. We don't have any destructor issues, I don't think. Here's the launch. This will basically move everything out into a place where I can find all the pieces without digging all the way through game scene. We do need a couple more features though. There's nothing else airplane related. Okay. Launch. Perfect. Okay. We're gonna launch way more often. I think we have the entire animation running in. I'll take a look at it. It should launch fairly regularly. 5 or 6. I don't want this plane launching all that often while you're playing. It'll probably be on like a multiple minute timer. But it's not too bad. Okay. So in okay, not all that complicated, I think. Set a fine rectangle. Let's just get this rectangle out of here. I don't think I want the quad have its center set. I think I want this object, which contains the quad. Okay. Update, render, blah, 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 launch. Let me think. Okay, so firstly, underscore airplane is underscore quad. Oops. Doodad airplane needs renderer. Animation. Action sequence and a scheduler. Okay. This is weird. The quad is a child, so we just rotate the parent and we're good there. Quad enabled, play a sound. Oh, I forgot about the sounds. Okay. Is that it? Okay, so we'll go to our make file. We're going to start a whole new section just for doodads. This will be fun. There we go. Okay, we haven't broken anything yet. So if we go to GameScene, we can remove everything airplane related. Sort of. Airplane needs to get updated. Airplane needs to be rendered. Airplane does not need any initialization here. We don't need to position the airplane here. This is important. We still need to do this. Let's go to airplane. Cool, image score is running. Stop. So let's say we are running by default. In update. If we're running, we update the timer. The timer is running. Timer should be stopped. Launch. When we start the timer again here, this is predicated on m_is running. So we only relaunch. So if we hit quit while the plane is midair, it means we started a timer, and as soon as that animation finishes, it was going to try and restart the timer, which would just start the loop again. We're just going to short circuit that. So if we hit the end of the animation, if we're still running, start the next loop. That's the main key. When we say stop, all we do is m_is running equals false. You know what? Let's not even do this. If the timer's running, we stop it. That's it. So it starts up in a startup state, and it runs until we tell it to stop, which happens in GameScene here. One last thought I've had is I do want the doodads to stand out to me. So m_airplane doodad airplane. Oh, this launch airplane goes away. So you have update and render and stop. That's basically it. Is that everything we need? Let's see how close we got. Shoot. Until we update that. Well, we'll know next time. For the ball or the bubbles being moved around the chalkboard, we may start with these broken out into a separate doodad thing. The ball and the bubbles will have a lot of shared code to keep them bound inside the chalkboard. Okay, so I have a couple of issues. Oh, my doodad. URNG. Let's remove it for now. We have some options. We can have the game scene contain its own random number generator, but there's already one in the scene. So we could just construct our airplane. Uniform RNG distribution. Why don't we just pass one in? Okay. We've already initialized the RNG by that point, yes. Okay. Oh. Hmm. Yes, indeed. So, trying to think how many doodads to have in a given scene. I think one thing on the chalkboard, one thing on the bookshelf, one thing that flies across the scene. Those all seem reasonable. I think. Let's just make sure it still runs the way it should. It should be about 5 seconds for the plane, and then it should launch every second or two after that. Well, that is unfortunate. It's not right. Ah. Oh. I know what's going on. That's what's going on. Get rid of those warnings, and we're good. Okay. Now it should move. We didn't set the parent-child relationship between those two elements. Easy fix. Two, three. Oh. Now we've got it slowed down. It's not going to be that slow. We need to pick a reasonable height. So it's working. Good. Journal. Move out to its own class. Fly left, right, right, left. Let's do that. That's an easy one. Calculate arc from other factors. Okay, so if we're gonna do this, we're gonna Fly left, right, right, left. When we launch. All that really needs to happen is we flip-flop the angles if. So m_urng.2. I think I have a coin flip, which is a very efficient way to get a random number that's a yes/no. Basically, when you generate a random number, you generate some number of bits typically. In this case, we generate 31 bits, so we get a positive signed integer out. Well, that's not very efficient for a coin flip. If every time I want a coin flip, I generate 31 random bits, it costs. So, one thing we did is inside the uniform random number generator, it generates one random number to use for coin flips only. Then it just goes through the coin flip and gets one bit, one yes/no for each of the 31. When it runs out of all 31 bits that it's coin flipped against, then it generates a new 31-bit number. So you get one random number generator, one random number generated for 31 coin flips. So right, angle 1 equals 10. And I wonder if the heading velocity will just work. That would be nice. We'll watch a few launches just to see what the left-right looks like. Make sure the angle's updating correctly. Of course, a paper airplane in flight is not described by a circular motion, but for the length of the arc and given the artistic fidelity of this game, it's a reasonable enough approximation. 3, 4, 5. Is that upside down? Okay, go the other way. It's upside down. We are super close, but one thing we can do is we can set scale. Scale 2. One to one. Doesn't cause any major issues in the normal case. But in the case where we need to flip it, we need to scale -1 on the y-axis. It'll just flip the image, in theory, vertically. I think. I hope. That or we have to do weird things where we flip the UVs, which is not that hard to do if we want to. So we'll just see what it looks like. Okay. Did I not build it? I might not have built it. Oops. Embedding all of our assets. Yeah. Maybe we just flip the UVs. It's not the worst thing. That's probably better than the affine. Because the top of the rectangle, the bottom of the rectangle, we measure from the top left. So it'll pivot around the top, it'll scale around the top left. Shoot. Let's go look at texture plot then. Flip vertical. Flip horizontal. Texture slot. It's defined somewhere. Where's that defined? There it is. Okay, I'm pretty sure the position. Hit UVs. Oh, here's XY. There we go. Okay, there we go. There's our pound defines. Now we never have to worry about that again. That's not the main issue. The main issue is set texture, set UV. I kind of want those up, but we're not gonna do it. We're not gonna do it. Okay. Picture quad. Take our current UVs. And change them roughly like so. That's not quite right. So it's going to equal something. And what we're going to do is we're going to flip U. Let's see here. U0 and U1 and flip U2 and U3. So we only have to make those changes here. I think. We'll try it. Hey, AK Elements. How are you doing? How was your stream? Good progress today? I'm going to store this one. Store 0. We're going to flip the V's vertically, and then with V. Take the second one. Set it to the third one. Then use our temporary. That's basically the algorithm. Yeah, what's new? What's new? Your graph editor for your shaders. Pretty cool. There we go. In theory, which means in the airplane class, I like this scaling. So we're going to do m_quad, set UV to the default. It. Image warehouse is capital default. If we coin flip vertical. because it was called view in this one. First version is done. Yay! I can generate basic vertex and pixel shaders, but yeah, I'm missing the nodes to generate more complicated ones. Yeah. Doing some lighter things currently, polishing the UI of the editor a bit, adding some more features. Nice! Yeah, UI is super important. A lot of people, I think, underestimate the importance of good UI. Like, you can spend 90% of your time on the UI. Let's see, your added toast notifications to the UI, so you can now show small toast notifications on the main window, and added today a sync for my logger. Okay. That forwards warnings and errors to the UI using those toast notifications. So if a user designer creates errors with his content, they get toast notifications. Don't need to read through the logs. That sounds handy. Yeah, log diving sucks. Cool. Nice. Sounds awesome. So out of curiosity, how big is the full running package for your game engine? Like executable DLLs. Why is that upside down still? Did I not flip the UV? Quad flip vertically. Simple texture quad. Should not be so hard. 0 gets 1, 1 gets 0. 2 gets 3, 3 gets 2. Oh. Oops. Vertex 0, vertex 1, vertex 2, vertex 3. Not sure why I deleted so many things. No. Are 8 UVs per quad. 0, 1, 2, 3, 4, 5, 6. Yeah, that's 8. We set 4 of them if we're doing vertical. 4 if we're doing horizontal. Very strange. Debug's about 35 megabytes. Oh, that's not too bad. I was thinking about doing toasts as well for logging. This sounds cool. Just using the standard IM GUI logger right now. Yep. Nice. Toasts for logging. Take a look at IM GUI notify. Yeah, I had to tweak it a bit, but it was decent head start. Yeah, I see the repo. I'll take a look. Okay. Yeah, I played with IM GUI a little bit when I was first picking up OpenGL. It makes a number of things quite easy. I am GUI notify. Sounds like a nice addition. Cool. No, as a user, that sounds great. Getting the notification of an error when you get it, not having to dig through logs. Except, of course, to find root causes, but nice. Well, cool. Cool. If I flip it, I'd say it's dirty. The vertex buffer is dirty. On render, if it's dirty, clear the flag, and it should force the update. Find our texture. Let's try flip horizontal just to see what that does. How do you handle editor UI in this project? My project or AK's project? Oh, he doesn't. Yeah, I don't have an editor. I have options other than GUI, but a lot of them seem to be paid or have weird licensing things. Yeah. Yep. I'm not using any. I'm using. Here's my list of dependencies. Are you ready? That's it, right there. Glue GLFW, which kind of come together when you use GLFW. And also bring in my OpenGL. I'm limiting myself to 3.3, no extensions. And then my only real dependencies are GLMath and FreeType for font rendering, and then port audio for my sound. That's it. So all my UI is handcrafted from scratch. And yeah, there's no editor. But AK Elements has a lot more experience in that realm, so. Oh, you are using IMGUI. Okay. How is port audio? It's very simple. I like it. You want to take a look? We can take a look at it. So in sound, oh, this is your source sound. You just include port audio. It's a single header file and a statically linked library. So there's just two files you need in place. This is all my junk. You basically create a structure of data that contains everything you need to know to render out the sound, right? So, oh gosh, so like I have an is running flag. Here's the stream. If I generate a frequency, like a sine wave, there it is. That's the frequency. If I'm using a recorded sound, here's how I look up the sound data, which in this case is 16-bit PCM, but you know, irrelevant, doesn't matter. You just kind of keep track of where you are inside of that, right? Sound. When you initialize, blah blah blah. Here we go. Initialize sound. Here we go. You do something like this, and it's actually fairly cookie cutter at this point. You want to output 2 channels of data. I want to output it as a single precision float. I get the default latency recommendations. And then I say, give me an open string for this sound object. And then I initialize that struct that I was talking about. A lot of this stuff is not used or not used in every case. Then when you say start, let's see here, where's the start? Oh, play. I set the flag, say it's running, and then I make sure that the stream is stopped. If it's not stopped, I force it to stop. Then I say start the stream. And that basically sets up a callback. It spawns off threads, and then it calls this callback. And what you do is you get your signal data back out. So this is the struct we defined. It's passed back in to us as a void star. We get our output buffer, and we're told, here's how many frames of audio we need per buffer, and then we fill it up. So depending on, so like we do some math around volume. If we're playing a recorded sound, then we get our samples, and we I have time morphing. I get my left and right channels and shove them into L and V. So left value, right value. And then I keep track of my offset inside the sound file, right? If we're generating a sound like a sine wave or a square wave, these are different instead of recorded sounds. Again, I do some weird things around slowing down, speeding up audio. Once you get through all that, all you do is set that contents of the output buffer to the left and right value, and then keep track of, am I at the end of the sound? If I'm at the end of the sound, I return this flag, PA complete. Otherwise, I'd say, this is not the last frame, keep going. If you do get the last frame complete, then it calls the end stream callback where you can clean up afterwards. So it's actually not that bad. Like, that's basically the whole general flow of the API. Very simple, easy to use. We got waveforms, heck yeah. Yes, we do. So I don't know if that was too fast or too vague. Like, happy to look at anything else you want. But yeah, there's basically two callbacks. One for the stream that says, here's a buffer, here's how big it is, fill it up, and here's the data you passed me to keep track of your bookkeeping. It takes care of all the threads spawning. Really slick. And then an end stream callback, which is optional if you don't need to keep track of your bookkeeping for when a sound ends. So that's it. I like it. Like, I looked at some other ones, and they're just all too heavy for me. Like, I want something simple, and then I'll add my abstractions on top of it. How's the platform support for it? Pretty good. Like I said, it's dead simple. It's a header and a statically linked list. So let's see here. Port audio. I mean, I've only built it on Windows, so I can't like speak to its. But it says it's on Windows, Mac OS, and Unix, OSS, ALSA. I'll put this in the chat. The documentation is okay. There are things that looking at the examples won't get you. But actually, it's really easy to get up and running. Their examples aren't bad. Yeah. So I'm probably sticking with it. Like, it's the right level of abstraction for me. I like it low level, but I don't want to deal with Windows programming directly. I'd like that one layer of abstraction. I just use OpenAL soft currently, but I like the audio synthesis kind of stuff with waveforms. Yeah, it's kind of fun. We sort of started an experiment. So some of the junk that we were playing with, let's see. Where was it? Magnitude shaping, there we go. So one thing we were doing was saying, given where we are in the sound, so our sample count and the end of the sample, basically shape the way that the sound comes in and goes out so that those hard sine wave starts and stops don't sound so bad. And how long to lead in and how long to go out. So you can make it more of a ping if you come in hard, like if this time is really short, and then it'll fade out. Maybe the T out is longer, or you can have it cut off much quicker. It helps a lot, but I think what I really want is basically an array that describes a shape, and then we just interpolate across that array. So instead of this in and out with easing curves, just have one shape for the whole sound. So that would shape the magnitude, but then yeah, adding noise on top of it makes it sound less robotic. So you could maybe use like a Perlin noise generator, or maybe just do noise, or maybe you superimpose a low amplitude higher frequency on top of it, maybe with a phase shift on it. The number of things I want to try is way more than the amount of time I've spent doing it. So yeah, we were playing with some of that, taking the base sound form and trying to make it more useful, but I had to move on. Oh, like a filter, yeah. Yep. So yeah, there's a ton of things I want to explore with that, because I think I can make a fun little Turing machine music player based on just what's in port audio. But I gotta get this game out the door. I need to not get too sidetracked. I was talking to my friend about a game that modifies the audio or music based on the state of the game. Yeah, kind of like if you go into the corrupted area in Terraria and the audio gets distorted. Yeah, so there was a game, and it's bookmarked on another. What was it called? Like Snowfall or something? Snowfall game with sound that changes based on user input. There's like a GDC article from ages ago. Adaptive music. Not Snowfall. It had some, so there was like falling snowflakes, and depending on the position of the snowflake when you clicked it, would change what the next letter was, the next note was going to be. And it was, so the faster you clicked, the faster the tempo went. And what was it called? Snowfalling game. Sounds of the snow impacts. No. GDC adaptive. It wasn't really adaptive though. It was user directed music. I'm trying to remember what the name of the article was, and it's on my other account. So I'm not seeing it here. Sorry, I'll have to dig that up though. It was kind of cool. I feel like I've seen a thumbnail like that for a GDC talk. Yeah. No, adaptive music would be cool. My sister is so musically talented. Actually, I have two super musically talented sisters, like in piano performance and in composition. And they're both very strong in music theory as well. I really want to do a collaboration with one of them to build something that's adaptive music, but like, I don't know, be a little different. Like my sister wants to do a puzzle-based game based on music theory. Basically, where you teach music theory without telling people you're teaching them music theory. She just sent me a document today as a starting point. Oh, it looks so fun. And I know nothing about music theory, so it could be cool. So yeah, let me know if you have any other questions, like about sounds or whatever we're doing. I'm literally just trying to do the minimum number of dependencies and build a game just from that. So we're kind of towards the end stages. So we're in the making things nicer and better for the user. We're adding Doodads today. So little elements to the scene that you don't interact with or that don't affect the gameplay. Like an airplane that flies across. That'll fly faster. I just want to see it. Oh, okay, so it did flip horizontally. Which means all I really have to do is change these. Well, instead of 0 and 1, 0 gets 2. And then 2 gets 0's value. So it's 0, 2 swap, and then 1, 3 swap. This is 1. I think that's the difference. So put this vertically. When the plane flies right to the left, it should be more correct. Heading out, super tired today. For my stream was a bit shorter too. Okay, yeah, get some rest, and I'll be watching your stream later just to see where you're at. Thanks. You have a good one. See you tomorrow. So LPC Kangaroo, what kind of projects are you working on? OpenAL is a pretty heavy lift. Are you using it for? I mean, it's augmented, right? So you're looking for augmented reality types things. You're mapping of the real world to your virtual world, or does it just happen to bundle enough pieces for you to use for non-augmented reality type things? Okay, you're playing left to right, fine. Right to left, there it looks better, so the flip works. Cool, done. Okay, so that's that one. We're flying left to right, right to left. Oh, I write an engine as well. Cool. What are you using as your basis for your engine? I'm just trying to get Pong to work. Yeah. Once you have Pong, like you have everything, right? You got your time step, you've got your input, and you've got rendering. I like the progress you have on your game. Thanks. It's what are we at? 20 some weeks now? 21 weeks almost. I did have some work done before, but where am I at? Recordings. Week 20. Yeah, we're just about done with week 21. Yeah, I feel like we've gotten a lot done. We're close to 25,000 lines of code. Oh, well, yeah, closer to 26. I'm trying to get networking going on the game currently. Oh, you want to play man-to-man Pong across the network? Awesome. Go mono-y-mono. And then I'll be done. Cool. Do you have like a GitHub or a video of your game engine? I'm always curious about other people's projects. They give so many ideas. And actually, that's a big problem with me. I have too many ideas and not enough time. Staying focused on one task or on one project is so hard. Okay, so let's see here. The duration I don't care about. We'll come back to that. The angle we may end up computing. So the pivot we're setting in the center of the screen, so it'll always be centered at the apex of the arc. Pivot Y. Let's just set it low. Yeah, 1.5. We basically want to know what's the lowest thing we can do here, and what's the highest thing we can do. These were total random guesses yesterday, so let's figure out what the lowest thing is. What other random things do we have? URNG, coin flip, and then the time. So we're not. Is that it? That's all our uses of randomness. 1, 2, 3, 4. And this one, oh yeah, how long until the next launch? So this will be different. Okay. So let's see what the lowest thing we had before was set to. Ooh, yeah, send me link. Then there we go. Okay, Concargano. I'm probably mispronouncing it. I don't want to derail you too much from your coding though. Haha, I want to get into easing functions from a runtime UI. It looks scary. Are you ready? Are you ready? Easing functions are not scary. I think the documentation is in here. This was an excellent resource to start from. I'll put it in here. And this gives a nice visual to some of the things. Oops, that's all right. So here's another good resource. it's just math, and you just copy it. Like, it's just polynomials. It's not like there's anything too clever you can really do about it. So for me, I have one easing function that takes a method from that's a class enum, an enum class. Assert time is between 0 and 1, and then it just calls one of the functions, right? Or you can also call the functions directly. So if you have linear, quad in, here's what the function is, quad out, function is this. Piecewise functions, like the code is mostly in that C file, and the visual for the shape of the curve is mostly in that other link I put in there. But it's not that bad. And I use this all the time. It adds a lot of personality and flavor to things. I've added smooth step and smoother step here, even though it's not technically one of the easing curves that are common. But like using smooth step and smoother step in Perlin noise generation and whatnot, it just felt like an easing thing, right? You have a value between 0 and 1 that goes in, and you get something that comes out that's roughly 0 to 1. There are some that overshoot, so like elastic, those will go outside the 0 to 1 bounds on the output. So the input still has to be 0 to 1, but this will output something that's outside that range potentially. So you don't have guarantees on the outputs for some of these curves. But there you go. Everything you needed to know about easing curves. It's really not that bad. Oh, I think I've seen someone show the second website too. I didn't save it. Yep. Yeah, no, it's awesome. Yeah, as soon as you have like just a single library for easing, use it everywhere. It's awesome. Oh yeah, so I was looking for GitHub briefly. I'm not gonna spend too much time, but I do like seeing other people's projects. Oh, you're focusing 2D for now. Good, good. A game editor. You have a runtime, a server, and a core engine library. Yep. Windows 64-bit. Visual Studio. Up to C++ 20. Git Vulkan. Oh, you went Vulkan. Wow. I started going down the Vulkan road, and then like, I don't know, 400 or 500 lines of code in, I got distracted by something else, and I haven't gone back. So I'm still doing OpenGL. And like I said, keeping it simple as I can is kind of the watchword for this project. Pong clone, yep. Oh, a breakout clone. Good. Multiplayer slap game dungeon crawler. Cool, cool. Third-party dependencies. I like that you list your dependencies and their documentation. Oh my gosh, thank you. Hash library. I am GUI. MSDF. So you're okay. MSDF for fonts. OpenGL, OpenAL. Profiler, STB image. That's very standard. Cool. Nice. I'm liking it. Oh, okay. So you just need to manage the time part externally. That's the part that confuses me. Okay, here's what I'm doing. Are you ready? I have a thing I call an egg timer. Ooh, this gets a little complicated. Okay, so let's go to time. In time, I initialize some 0 values basically, and then I saw you had GLFW as a dependencies, right? That's what I'm using for my time. I don't know what you're using for your time, but all I do is I set GLFW set time. Then at the top of every frame, I call this, and it says get time, computes the real time difference, and then stores the current time, right? So that we have that for the next frame. Then I have an option to scale time and compute that. So you can either get the real time clock or you can get the scaled time clock. That lets me do things like this. I don't know if I have a good playback right now. Let's just do a quick play here. Let's fill up the board just so you can see kind of what we're talking about. And then we will lose on purpose, right? Fails. Okay. Now we're going to leave. And we're going to watch the replay. In replay, we can actually scale our time. This is why my sound also has a bunch of junk for scaling. And when we hit play, we can go, 1/4 speed up to quad speed. Actually, yesterday, we were just testing. We hard-coded everything up to 100x speed, and it still ran. If I give it a little bit more resource in an arena allocator. So anyways, that's time. So that's time. Time is simple. Don't overthink it. Literally, what was my last time? What's the current time? Subtract the difference. If you want scaling, you can, but you don't have to. Like, not necessary. Then I go to, let's see your time. Egg timer. This lets me keep track of things like whether or not we're using scale time. Allows me to set a duration. So a lot of my animations, things moving, are going to use the egg timer. Does the egg timer cycle over and over again? And then dinging, did it complete that duration? So in my update loop, update. Elapsed, blah blah blah, start time, blah blah blah. Basically, it's using the time thing to keep track of its own elapsed time. And its elapsed time is going to be an accumulation of, how much time we've stored up. Elapsed, yeah. Anyway, so egg timer, we can set a callback, and it will fire that callback off when it runs out of time. If it has dinged, so far, elapsed time is greater than how long it's been, how long our duration, right? So it has dinged, elapsed. Here we go. What's our t? T minus our start time is the result, and there's how much time we have elapsed, and then remaining is our duration minus our elapsed. Here's the normalized 0 to 1. How far from 0 time to the end do we go? And that all is used to drive an animation. So this animation has a timer, right? And we can set a duration. And if we say start, it just starts the timer. That's it. You can pause the timer, stop the timer, reset the timer, mark as idle, blah, blah, blah. But here's the update function. So we get our timer's normalized time. So what percentage of the way are we into the duration? Or you can do a custom thing. Clamp it 0 to 1. Then we apply our easing function to get a parameterized time. Right, so this is our 0 to 1. We apply an easing curve, we get this out. And then we apply it. Right now we're applying a single value. So if you give me a range of float to float, we'll interpolate it and kick out we'll apply the value. That one's less interesting. Points, so you can give it an X, Y, and it'll interpolate between 2 points. You can give it 2 colors, and it'll interpolate between those. Apply is basically where a callback you pass in. So when we're going to like the airplane, blah, 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 I set the range. I say we're rotating from this angle to that angle, and here's how you apply it. So this is a lambda function. We're going to go from this position to this position, computing an angle. We're going to move by that parameterized amount, this angle here. This angle is the interpolation between this angle and this angle, using the parameterized time. So animation. So we set our duration, 3 seconds, easing curve, and here's the range that says from here to there, this is how you apply it. So this animation has an update which updates the timer as well. So this update, all it does is update the timer. That's it. let's see here. So you have a struct to hold the state, and that interacts with the function. Yes. Oh, so it's like animation instantiates an egg timer. Yes. Which feeds time data into the polynomial easing function. Correct. Egg timer is useful for other things. That's why I have that broken out separate from animation. Like sometimes I just want a thing to fire off every so often, and it's not an animation. It's just count on this timer and then do a thing. So egg timer I separated from animation, but animation is built on the egg timer. So yeah, that's not bad. I guess I was just in my head about it. No, and it's easy to get lost. Like there's so many things that you can do. Like this is not the only way to do it. It's just the one that I like. So yeah, now you have all the polynomial code for the easing curves. You probably know enough to do a timer and an egg and an animation class. Not bad. And if you want me to describe anything in greater detail, I'm happy to do that too. I just happy to chit chat about code. And there's a lot of things about programming in complex systems where it's like you do get in your head. It's like, well, what if this? What if that? What if this other thing? But if you break it down in the right places, it actually comes together pretty automatically. Okay, so we're doing a low arc, left to right. I think. Did we build it? I don't remember if we built it. So after a few seconds, the airplane will launch. So that's our lowest arc? No, we must not have built it. Okay, let's go rebuild it. Oops. Fat fingered something. Yo, I'm head out. I'll drop by your next stream. Hey, yeah, thanks for dropping in. And let me give you real quick the old Discord server. It's not terribly active, but you'll know when I go live if you're interested. So yeah, thanks for dropping in, and feel free to drop in anytime. Talk to you later. Okay. Oh, I'm starting to get information about my music. Yep. Peace. Peace out. Okay. Where was I? We were building this. So the lowest combination. Okay. That is, yeah, that is the lowest combination. We just want to make sure our random values have a reasonable range. So the lowest possible airplane we can get with this setting. That does not feel right. That's the lowest? I've seen lower. Okay, what's going on here? Oh, because the pivot y is down, so 2.25 is the lowest. I keep inverting my y-axis. Y is positive up. So my pivot needs to go down further. Okay, that's too low. Much too low. We're just going to play with numbers a bit here. most of the time it'll probably average out to across the middle of the screen. But we have to know what the extremes are before we allow a random number generator to pick it. Oh, that is actually not bad. Maybe just a tiny bit higher. That's like right across the bottom of that screen. Like it just touches those corners. So I guess we got lucky picking our first initial values. That we were that close. So try 1.5 and the extreme 1.75. So that should be near the top of the screen, but I don't want it to clip the top. So we may need to drag it down a little bit. I saw one or two flights that were pretty high. We'll see if the extreme is too high for us. All right, airplane. It's out of sight. Okay, good to know. I'm going to take a quick restroom break and open the window. It's getting warm in this room. So just a minute, and then we'll keep checking our boundaries. Be right back. Okay, so we need to change the height at its highest point. I like the difference in radius, so maybe we just 1.5 to 2. What if we don't change the pivot? All right, here's another thing we could consider. Instead of changing the pivot, we just change the radius. Or, wait, did I say that right? Did I mean it backwards? If we just change the radius and always leave the pivot in the same location. So if we lock pivot at 2, hard 2, what if we do this? We say hard 2, 1.5. So we're just not going to move our radius. We'll just move the pivot. That's probably simpler. Hey, Suki, how's it going? Welcome back. All right, plane's gone. Shoot. Where did it go? Pivot by 2. So right now, 2.0 is not that bad. We're somewhere in around 2. Great. I'm doing great. We are adding doodads, little non-game elements to interact with and look at. So first thing up is an airplane that flies across the room randomly. We're just trying to pick a set of heights that we can randomly pick between right now. But we basically have 2 bugs left, adding some doodads, final art, and final music. So that's very low, but not as low as we can go. So 2.5, 2.6. We're going to find the lowest point. I like how in dramatic arts, the teacher made us memorize 3 texts just to put the movie with those 3 texts in it. What 3 texts were they? Okay, 1.6 isn't bad. or 2.6, 2.7. That might be our lowest bound. Well, I'm less of a I'm not opposed to forcing people to memorize stuff. The human brain, especially with some training, is amazing. It is fascinating how much stuff it can remember. And the true innovative geniuses are often combining different ideas that have lived in their head for a long time, right? Being fully immersed in information to the point that it's in their brain enough that their subconscious can start making weird connections. Okay, so I think that's about as low as we want to go. So let's go up. So this is our quote-unquote lowest. And we said that 2 so maybe like a 1.75. We can see where that ends up. One is like stop right now. Then there's a poutine with fries, and there's the I missed my bus. At the end of the second person says that she's pregnant. Okay, I don't know any of those. I did not. Let's see here. I did a couple of plays, but I never took it too seriously. I do have 3 or 4 friends that are very, very into acting and plays and drama. They're my D&D group. They all take the same plays. It's kind of funny. Okay, I don't see it, so let's go lower it. 2.0. But I always like those elocution practices. You know, I shot a hippopotamus with bullets made of platinum because I put lead in them. His hide would surely flatten them. Or like the announcer's test. That's always a fun one. 1 hen, 2 ducks. Announcer's test. It gets more and more crazy as you go. Let's see. It's basically they would use this one as a. Well, that didn't link properly at all, did it? Lame. Well, copy paste the text instead of linking. Click the link, but they would make radio announcers read and memorize this thing, because if you could say this clearly and read it out properly, then they could put anything on your cue cards, and you'd read it and be able to read it clearly and neatly. So that's kind of fun. Also just a good exercise in memorization. Okay, that's really close. It's just getting clipped at the top. And also the arc is too long. So 2.05. Because that moves us down. You just need a little clearance at the top there. I think I'm just a little too self-conscious to be a good actor. Oops, open my window. There it goes. Perfect. Isn't clipped at all. Okay, now, last piece that we want to do. This is going to be... We'll come back to this, but this is our range. 2.05, 2.75. The last piece we want is actually this Engels arc. And what the question really is where does the plane appear on the screen, edge of the screen? At what angle? Which we can compute. So global pi minus angle 1. Now all we have to do is compute this one. And all we really care about is a cos of the width of the frame over the radius. So what we want to do is take cosine of an angle times the radius. Pivot x is 0. Well, it's the midpoint, but that's fine. Frame width over 2 times the radius. So if we take I don't know, without writing it on paper, taking it through more detail, we're just going to try it. Okay, it disappears a little early and it comes in early, but I think it's the midpoint of the plane. So all we have to do is take this okay, I'm gonna write this down. Down here we have pivot x plus radius times cosine of an angle. And I know where I want this point to be. So if I take the point I want it to be minus some offset, which is actually half the width of the airplane. Sure. Then we can ignore that thing. This is basically our px1 divided by a radius. Okay. So frame width divided by 2. Let's flip this logic around. Radius times this plus our width. I think that's it. So the plane should start one plane, half plane width off the screen, and disappear after it's traveled one half plane width completely off the screen as well. I think. So there'll be less dead time on the high arcs. Or the low arcs. Also, the higher it is, the faster it will go. No, the slower. I don't know. We'll just watch it. Okay, so this is the Nope. Nope, nope, nope. Incorrect somewhere. Trim width over 2. Plus the rectangle's width. Even if we have the width, I don't know if that makes the difference I want it to. Divided by radius, then a equals that. Oh, divided by the radius. What am I doing? Why am I multiplying by radius? Divided by radius. Wow, okay. Radius, there we go. Multiply and divide are two different things. Can't use them interchangeably. I should remember that. But I was looking at the wrong side of the equation. I was looking at the part where we're multiplying the radius times cosine, not dividing the a cosine by the radius. Well, dividing the, anyway, yeah. Theory, this should be better. Okay, and then airplane flies and fully disappears. Perfect. Airplane flies and fully disappears. Great. So that's the highest airplane. Let's take the lowest airplane. 2.75. Maybe we'll make that a little lower. We'll see. Got a good amount of work done this morning on logo, company logo, and company banner. So there's the low airplane. It is not popping in and out of existence, and as soon as I get the wish, it's flying across the screen. Okay. So I think that's our random range. There. This time, .75 and 1.25. Give ourselves a couple of different speeds, or a range of speeds. They should go faster. Then we'll set a longer range and ignore it. Plane will be done. Okay, let's just watch a few planes fly around. Oh, that was quick. Okay. Seems good. All right, last piece. We need to make this not launch quite so quickly. So we're going to launch every between 1 and 3 minutes. Which also happens right here. 1, 2, or 3 minutes. No, let's get next float. Let's make it a little bit less. And there we go. I think we're done with airplane for now. I should probably put the airplane in the scene elements image. Maybe. Okay. So the plane should launch every minute, minute and a half, 3 minutes. Okay. Laced rhino, therefore. Those are all out. ACH. Oh, interesting. It can't be so there's an imaginary word here, match, which must have A or C or H contain 2, but it can't be both C and H, therefore A is guaranteed to be in. Ultra Demon CHI must contain 1. ED LC can't contain more than 1. Oh, wait. We know this is true. Hey, there's an airplane. LC can't contain more than 1. So it's A, E, D are in. It must be L or C because it can't be both and it can't be neither. So U, N, H are out. Therefore, the rest of these are the rest of LC, LTRAM. Oh, let's see here. Because of laced rhino, stump, those go away. L or R. Proud lines MAC must be C and not L. O I 1 2 1 2 2 1 2. Okay, I think we're good. So it's cadre, gator, raced. Read. Oh dear. I like ED at the end. Acred. Cared. Oh, come on. How many are these? Raised. Acer, cater. Cedar. There we go. Hey, there's a lot of palindromes in that one. Laced rhino. Proud lines. Aha. TCH. Then we need more letters. BD. Logs. Oh, there we go. LOS. It can't be N and O. D is out. NO. LNS. LA. So U is out. LN. BAY. Oh, O is in. Okay, N is out. L and S have to be in. A has to be out. Therefore, BY has 1 and not that. Interesting. Okay. Logs. Jacks. Waxed. All right, so it is by or wx. By wx. Something like bowls. Wow. Okay. Blows. Perfect. So that plane does fly through, and it doesn't seem that annoying yet. Ooh, okay, it's W or X is our last letter. So maybe like straw. Warts. What are we doing? Oh, we're in a marathon. Okay, so while I'm sitting here, I think if people are annoyed by the doodads, we need to give them a way to turn it off. So that is on my list of things I think I need to add. BD, good, logs, good. BYFG. Let's try B. B is out, Y is in. G is in, F is out. Home. Here. Young. There we go. Ooh, took me a while to see that one. Okay. Proud lines. MATCH. LTA. So let's copy these over. LT not A. L not TA. Not LTA. Alright, looking for contradictions. S goes away. IME. EMN. So it can't be N. It has to be E or M, therefore I. Oh, and E is in. H is in, N is out. Okay. So something like live. Not bad, not bad. We're gonna finish our first marathon since I've started streaming. Prime lunch. So it just takes so long, and we're mostly watching to see how distracting the plane is. Toads, laced, rhino, stump, STMUMP, TOS, demon. Okay, so we have enough information to look for contradictions. So MO not N, M not ON. There we are. Now looking for contradictions, those go away. U or R, lunch, UH, demon chips, CHIP. So HIP. Ultra, let's see here, laced rhino stuff, STUM. It's U or P. Let's look at this one. Anything good here? T or R? P or S. These are in. P is out. Not seeing a word right off the bat here. Rims. Nerves. Smurn. Okay, let's see what else we got here. Those go away. T or R. R or I. Oh, invalid. Proud. Okay, I goes away. PR is in, H is in, U is out. Morph. Huh. That looks more like a word than this one does. Oh, and this one has contradictions now, so good job, us. Morph. Whew. Okay, there goes an airplane. Okay, I'm not feeling too bad about the airplane. I think the airplane looks good. Doesn't fire too often, but it's often enough to be entertaining. Therefore, journal. Calculate arc angle for other factors. Okay. Airplane Doodad has been tightened up and tuned. It looks pretty good. I need a new task though. Button in settings to turn off Doodads. Okay. Let's save our work. Oh, yeah. Then we'll start a new Doodad. I think it'll be the physics-based ball. That'll be a good one. Airplane Doodad is done. A button. So we're going to set it. Let's go to game context. Static bool use Doodads. Defaults to true. So that's part one. The next thing we need is application. Practice guesses we do not store, but master volume we do. Int HT S underscore use Doodads. Look for master volume anywhere that appears. Read a value into Doodad. There we go. So there's that. That's in reading. If we want to save a config, master volume, right there. So the Boolean one, int 8t, use Doodads equals in context use Doodads. Question mark 1, otherwise 0. Use the Doodads. Okay. We'll comment this one out. I'm going to launch once so that it's into our configuration. When we're reading one of these in, is there an assert? Greater than 42. Oh, no, not yet. Okay, so we're going to launch. And when we exit, we'll save out the Doodads flag into our config. No. Oh, offset equals buffer size. Offset equals buffer size. Buffer size. What are we calculating our buffer size? 42. This happens after these animations. Then use Doodads. There we go. It will technically pass. Okay, let's just run it, see what happens real quick. Okay. Seem to have run out of gum. Oop, there we go. Okay. Once we get both the read and the write on the same page, it'll be easy. Ugh. $42. And load the config 41. Okay. Okay. Boom, we're not doing anything with that. $42. I know how to fake it. Main loop, close request. We're just going to do this. Then we're going to delete our config file manually from whence I hid it. So C users the dough, app data, roaming, last penny game studio word sleuth. We're just going to delete the config. Goodbye. Now when we launch, we'll take the defaults. I want a big screen. When we quit, it should write out successfully. My config. When I launch, the window should be at the right size and place. Perfect. Okay. So that's all there. Now, settings scene needs a new button. We have a button for animations. We need a button for Doodads. That's basically it. Doodads. Okay, animations clicked. Doodads clicked. Okay. So button doodads. Just shift everything down below it. And that's it. The last piece is in Doodad Airplane, where it sets itself up. Really doing it this way. If we're enabled, update. If we're enabled, render. Okay. Enabled equals, we're going to the game context. Use doodads. Okay. So in theory, the user should be able to turn off doodads if they want. We do this as early as we can for the user, because if I wait too long and have a million doodads, it'll be impossible to actually do it. So settings, crash. Oh, right, I know why. Need to tidy up and then debug build. Okay, settings. Doodads on. Doodads off. Was that a bad exit, or was it a... It is a bad exit. Anyways. So it is remembering it's off. If we quit, it should write that out to our config. And then we load. It still remembers that they're off. Okay. All right, is that just a frame drop problem? It's an animation problem. Those frames didn't do much. But the doodads are off, which means we're getting marathon mode. Okay, that's just wrong. Whatever we did there. Those all go away. That goes away. Rhino is all in. ES are out. DM is out. T and A are in. Okay, so our deductions look like they're right. Hey, let's see here. We're mostly just waiting for an airplane to fire off, which it shouldn't, so. Oh, ratio, that makes sense. I or E, therefore P and M are out. E or D, therefore WX is out. And O, it has to be in. Therefore, F or G, so like group. Oh, yeah. Forte. I've not seen a single airplane. Ooh, laced rhino. Not bad, not bad. Ultra demon laced rhino. Proud lines. ACH has one. Okay, I'm not seeing any airplanes. So let's go get settings. We'll turn the doodads back on. Whoops. If use doodads, start the timer. Okay. Theory, we have doodads enabled. Interesting word. Wow, that is kind of crazy, actually. B or K, but not both. J or W, but not both. Let's get an easy one here. If we get the Y, it must be K. It's therefore not J, which means it is W. So wacky. Interesting word. Let's just waiting for the old thing to appear, the airplane here. U or R? It's R. There's a contradiction. O or N. Those all go away. U goes away. R has to be N. P or O, but it must be P and not O. It probably has to be Y with these letters in this case. Over here. There's an airplane. F or G, so rouged. Urged. Okay. So the airplane does fire when you have it turned on. So Doodads is working. And it does save across settings. I'm going to fix that settings thing. That's just annoying. Settings, exit, not clearing all elements. Settings can now clear, enable, disable Doodads. Boom. Okay, nice. Doodads can now be turned on and off. is the center of the screen, the center of the object we're moving, magnitude. So just move further off the screen, right? Maybe. Oh, not that one. This one. Okay. This is actually interesting. That I want settings. There we go. Everything flies in. Ooh, so close. It has to do with the ratio from the center to the corner, from the center of the screen to the corner of the screen, not being the width or the height, but rather a distance, a Pythagorean distance here. We're kind of fudging the numbers here, but it should be 1.414, so 1.5 is greater than that. It should work. Yeah, they're cleared. Okay. Get to settings, exit animation. Okay, journal. Here we are. We got airplane in, and it's not that bad. We are going to add another thing. So journal to do. I'm going to take this one. A chalk drawn ball. Click and drag to lift and release to drop. Mini physics. We'll see how far we get down this one. So instead of doodad, we'll do chalk ball. Airplane. A lot of this is going to be very similar. We may use math. We need game context to know if it's a doodad. We need a texture quad. That's fine. Egg timer. Unclear. We need the image, the renderer. Maybe not animation, an action sequence. Actually. For now, let's not grab that. Let's keep this simple here. We're just going to draw something. Update and render. Stop. Let's not worry about stop right now. We need a picture quad, obviously. And that's most of what we need out of here, I think. For now. Let's see. Um, I'm trying to decide the best way to do this. We could use a text object. We could use a texture quad. Let's do a texture quad. I don't want it to look too much like the letters on the thing. Which means I have to go draw something real quick. Go GIMP. All right, we are going to put the airplane inside of scene elements, and we're going to put so we can get the let's show the right screen here so you can see what's going on. There's GIMP. Okay. Step one, we're going to steal out the airplane. Where is the... $760 seems fine. Active layer. Just gonna call it airplane. Nothing fancy here. Okay, so that's the airplane. Now we need a circle. And how big is our circle? Our airplane is this big. So I guess we can... $250 by $250. New layer, ball. Okay, edit. We need that. We need our color. Color. That's very white. What about our slightly off white? Not quite that off. Actually, let's go with like a nice bright purple. Okay, paintbrush. Where'd that grunge one go? Grunge? That's acrylic. Where's the grunge? Acrylic. pencil. Oils, where did grunge go? Smoke, sponge. Ugh. Five, edit stroke selection. That is rather a large ball. I think our letters are like 50-ish pixels. What's our large font size? Let me just check that real quick. GameScene. We don't actually want it to be that big. Do layout. Letter font size. ChalkBoard letter size is the height of the slate divided by 12. So 647 divided by 12. $53. So if we make the ball around 50, it would make it 45. I don't know. Let's make it smaller though, either way. Which means our paintbrush can't be that huge. Stroke the selection. Okay, it's kind of small, but it's not too bad. We take our paintbrush, put like a highlight. Or a dark light. Okay. Layer 2 content size, which is not there, it is over here. Prop to content. Just put it somewhere, anywhere, it kind of doesn't matter. We can put it here. So airplane and chalk ball. I'm going to export this as scene elements 1. Export UVs from layers, but we have to hide this one. 16 elements, 1, no prefix sorting is fine. Go. Okay. I think that's all the work we needed to do in GIMP. So let's go ahead and hide GIMP. Tools, UVs. We no longer need airplane. Ooh, just change how we do doodad airplane things. Set texture. Scene elements 1. UV. Airplane. WH. Image warehouse. Get UV size for this thing into width and height. I think that does that. So let's make sure that comes in okay. Tools bin /embed PNGs for new data. While that's grinding, we do have to do that. Okay. You build with the image warehouse changes in it. Okay. Then we'll go start working on a chalkball doodad. I think a little click and drag will be great. Some fake physics. So kicks it as chalk. Okay. Just make sure the paper airplane shows up. I need it to show up a lot sooner. We're gonna what, 5 and 6 seconds. Just to be sure. Just make sure that your airplane shows. There it goes. Ooh, what? What? Airplane. What? I am confused. No, that should be fine for the airplane. That's fine. Set texture, set UV, get the UV size, set our quad accordingly. Did we not // embed our PNGs? I thought we did. Oh, maybe we launched this process before. Maybe this will work. Ooh, 3 o'clock, almost time for a snack. We should be able to get the chalk ball to drop pretty quickly. It's the interactions with it that should be a little more difficult. First thing we're going to do is click and drag with no velocity preservation. And then we will clamp it to within the bounds of the chalk drawing, of the chalkboard. Things like that. I'd like a pirate day. Place a paper airplane with a parrot. Okay, so paper airplane should work now, right? In theory. Two, three, four. What? Oh. I know what's going on. I know what's going on. It's not the only place where we're calling set UV. We do it right here. We're overriding our own therefore. Therefore. I thought the size was correct. They sized it once on construction, but then when we launched, we were resetting it. So that'll fix that. That'll be good. If the plane shows up correctly, then we'll move on to the chalk ball. Okay, plane's good. Okay, chalk ball. Okay, set elements, scene elements 1, and it is chalk ball. I wonder if we'll do more than one chalk ball at once. That could be kind of fun too. Enabled is true. Do that. All that makes sense. To bring in nothing timer related. Oh. Enabled equals use Doodads. Update. We'll do nothing. And render. Chalk ball. Okay. This should be enough to put in our makefile. Which is at the end of our object list. Good having so many things going on now. Okay. Okay, chalk ball. We want rendered behind the letters and things. We want to render it on top of the chalkboard, but behind everything on the chalkboard. Okay. Don't need to do anything on stop. So let's just we need to put it somewhere though. So in do layout, we have a chalkboard X, Y width height. We have a slate X. X, Y, we don't have the slate width. Interesting. I think it's interesting anyways, so let's see here. Doodad chalkball dot set or move to chalkboard X, chalkboard slate X plus doesn't matter scale we have the chalkboard width, right? Really? Chalkboard W. Yeah. What's this divided by 2? That's our x coordinate. Our y coordinate will be chalkboard y plus this. Let's see, let's put this on its own line. Plus the slate height plus the chalkboard slate y so top edge of chalkboard, bottom edge of the brown border of the chalkboard plus the height of the black of the chalkboard minus Doodad chalkball dot rectangle dot height. It might be height divided by 2. I'd have to think about it, but we'll start with this. Just see where it goes. All we want is for it to draw. Okay, I think we want to rebuild the image warehouse right now. We need to rebuild everything else except for the image inside warehouse. Okay. We'll get the chalk ball to show up. Oh, we didn't include it. Everything else seems fine. Okay. Then we will add mouse press, mouse release, and mouse move handlers. Yes, that's because it doesn't know what type it even is. Blah, blah, blah. We probably forgot to do a couple things in here. That's better. Okay, let's see if it shows at all. Whoa! Well, it's huge. And definitely not where I want it. Oh, I think I know what that's about. So let's get out of here. Doodad chalkball. I don't know why this says airplane. It should be chalkball. In fact, in our to-do list, a texture quad when setting UV should automatically resize itself. It's just too common and too useful. That would have saved me that trouble right there. Okay. So that should be the right size. The height doesn't look right at all. But that's okay. That might not be that far off. Like I said, it might be minus half the height of the ball, since we draw from the center of the ball. There's a ball. Let's put it down half half the height of the ball. Minus half the height. I'd actually like that just a tiny bit lower, technically. Still, that's not bad. That's not far off where we want it. And it kind of looks like a chalk ball drawing. Okay, so we need to do two things. We need to set the edges of the chalkboard. Well, okay, let's try this. Well, let's see. Chalkboard Y plus the slate Y plus the slate height one thing I would like to do when I go look at okay, I'm going to open Scene Elements 2. We're going to take a quick looky-loo. Where is the thing? We should show. Did the wrong thing. Layout Scene Elements. Okay, so we're going to show this. All I need is to know what these numbers are. Write them down real quick. So this number is x equals 52. And y should be similar, but not quite necessarily the same. 40, 57. Okay, then I need to know what my max x's and y's can be. Right there. So that's 1386. Basically, we don't want the ball to go outside these bounds. That is 1862. With the understanding that this chalkboard will be scaled, so I do have to be a little bit careful about that. But those are the extents of the chalkboard, which we must set boundaries on in the ball. So, dun. Doodad check ball. We need a function. We're going to call bounds. Bound x 0, 1, y0, y1. then we need a function. Void set bounds. X1, Y1. Over the range we're looking at, floats are fine. Okay. I want a function. Oh, and then set position 0, 0. Like it kind of doesn't matter. Put in set position, which we should be using instead of move to. Set position float x, float y. We're just going to clamp basically. If x is less than bound x 0, x equals underscore bound x 0. Greater than x1. Back it down, then move to x, y. Then GameScene does the following. Go check ball.set bounds. That's going to be from the chalkboard's top corner, chalkboard x plus 52 to chalkboard y plus 52 of 57 to this thing at 1862, and then y plus, oh, and these need to be scaled, 1386. This is renderer scale. All right, we're going to set bounds. Doodad chalkball.set position. We're just going to, well, let's not do this first. Let's just see what the default behavior gives us. Because it should be 0, 0, which means it would appear in the top left-hand corner of the chalkboard. Oops, close that. Hopefully we're done doing graphics today. We always want to clamp inside that region. And we may be off by half the diameter of the ball. We shall see. Oh, no, just about perfect. Okay. And if we put it down here in the bottom corner, hopefully, where we go chalkboard X plus chalkboard width, chalkboard Y plus chalkboard height. That should be enough to put it in the bottom right-hand corner. But not, it should be clamped. That should all be reasonable. Then we'll do some mouse work. Ugh. As long as it's clamping correctly, we should be able to do this. Huh, well, the center of the ball is in the right location. That is not where we want it. Oh, okay, okay. I know what to do. X plus rectangle width, Y plus rectangle height. Something like that. Divided by, yeah, so that should maybe do better. If this appears in the right place, it's going to be time for my jalapeno popper run. I think that's the rule. I don't chew so much gum. The jalapeno poppers are delicious. So well, that's half right. Good heavens. Oh, did we not build? Yeah, maybe we didn't build. Minus width. If the projected right edge is greater than x1, then we take that right edge of our boundary minus our width so that our right edge aligns with that boundary. We take the bottom edge, projected bottom edge, And if it is greater than y1, then we clamp it by saying we take the bottom, move up some amount. We're drawing from the top corner minus side of the ball. But it has zero, zero. We center this thing. X, Y, 57, 1862, 1386. And then we set the position off the edge. And off the edge. That should be clamped. Let's just take a look at what it's doing here. Chalk ball. To another point. We're going from r.x, r.y to x and y. And then we clamp everything. And we instead do that. So it shows us exactly how much we're clamping. In theory. We might as well put in the width and height while we're at it, right? Right. I don't know what the bounds are, so that's another good thing we could log out if it doesn't make any sense. When we set the position, it does this thing, which looked okay. But now we're overriding it with something else, which is getting clamped there. It doesn't clamp it at all. Why is it not clamping there? 1022, 357. In theory, $56, $56. So we're trying to move to here. I need to know what the bounds actually are. All right, we better print that too. X between 0.3f and modulo is 0.3 f inclusive y. Maybe there is something I'm not thinking correctly. M underscore bound x not. Oh, wow. Y1. Assert x naught less than x1. Y not less than y1. I wonder if I have a sign clip somewhere. Shouldn't be that hard to clamp a texture inside of a rectangle that we've already calculated. Oh, maybe. Or maybe I'm thinking about this problem wrong. This board this board size is a lie. Palette sided. Not sure what's going on there. So the chalkboard width and height are actually scaled down versions of the full chalkboard width and height. Yeah, let's try something different then. Running those values, what we need is chalkboard x plus chalkboard something slate x chalkboard slate y x plus chalkboard width minus this. Same thing here, basically. That width is height and x is y. All right, let's try that. So in theory, it should be in that top left-hand corner. Then we'll try and put it in the bottom right-hand corner again. Okay, That's not right. But it's off by 1/2 the size of the ball. Active processes exist. Oh, no. Cancel. Oh, something's busted. It's fine. We'll figure it out in a minute. X plus r dot, or minus, no, plus r dot w, divided by 2, plus r dot height divided by 2. Since we have the center rendering in a particular location, I think we have to add those offsets in to get that position. Okay, so that looks closer. Does the chalkboard have a depth? I don't think it does, but it should. ChalkBoard has a depth of 12. 12 times cosine, oh, for Pete's sake. 12 times 45 cosine. 8.5. Ugh. $8.5. Well, it was like 48 something. $8.528, sure. Okay. Now, instead of this, when we set these things, I want to set them to half width equals r dot 8, width 2, half height plus half width plus half height minus half width minus half height. Okay, that should fix one thing. Set position should not do that. at all. Oy, oy, oy. Fishing around here. Oh, interesting. Try this one again. Maybe I'll be happy with it. I won't spend much time on the edge anyways. But if we get the bounding correctly right now, it will be much smoother when we start clicking and dragging and animating things. So here we go. The question is, close enough? Close enough. All right, bottom right. And if that works, it's jalapeno time. Am I adding additional offsets somewhere? Oh, I am. We've already compensated for the width of the thing. So I think this will fix it, maybe? Question mark. There it is, bottom right hand corner. Perfect. All right, let's write up a little thing here, journal. Draw a ball. Count the ball's location to the slate of the blackboard. Mouse, click, and drag to move ball. Add gravity, velocity, basic physics. Damping, basic physics, and then lastly, add collision bouncing off edges. Sound? Maybe we want a bouncing sound, maybe we don't. Okay, so we've done this, we've done that. Part of the ChalkBoard Doodad. It is drawing and lamp. Okay, phew. Also move the airplane. You should probably add that note. Also move the airplane texture into scene elements 1. Airplane, texture into scene, elements 1, chalk, ball draws, and is plant to Blackwood. ChalkBoard. I've been calling it ChalkBoard so far, so not a good time to start changing my naming scheme. Yeah, just for consistency. Okay. All right, I'm going to go on a jalapeno popper run. Be back in a minute. Do I remember how to type this? No, 1, 4? Nope. Whatever. We're going to go with that. I'll be right back. Jalapeno poppers secured. Yes, I know that's not how you spell it. I don't know how to type a tilde N without digging around a little bit. So here we go. So we're in here. We need a mouse click and drag. So we need a mouse press, mouse release. Mouse press, mouse release, and a mouse move. So the best place to get a mouse press and release event, example. Oh, and actually this one, good. So over to Doodad chalkball. Dun, 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 dun. Press, release, move. Those are what we want. We do not care about the repeat. Okay. Over here, then button. Press, release, move. Except that we don't want repeat. Then we get these. And again, we don't care about repeat. And in the destructor, we need to get rid of them all. Jealous of the poppers. Yep, they're great. I mean, there's other things around here I could eat, but I can't eat them. It's kind of the tragedy of being on a diet. So jalapeno poppers it is. When we make jalapeno poppers, it's like one of those big Costco bags of giant jalapenos. It uses way too much cheese, but they're worth it. Okay, so that's most of it. We don't want a button. We want a Doodad chalkball. Please move on the press. Okay. What? Oh, very cute. Okay, wow. That's just unfortunate. Yes, no, yes, no, yes. No. We do not need this repeat. If we are enabled. And if the button, we're going to say it's right button. Everything else on that chalkboard is a left click. contains. That's the question. Do we contain this point? And the default contains is a rectangle check. We would rather do a radius check. So that's probably what we're going to do. Actually, regardless of whether it contains it or not, it's more about state at this point. Handle mouse move. If we're enabled and if we've been clicked. Okay. Chicken, bacon, cream cheese. Yeah, you do about 50-50 cream cheese and a good sharp cheddar. That works out pretty good. Then you bake it at, I don't know, 425 for 25 minutes or so. We put them on a cookie sheet and then cover the bottom of the cookie sheet with like tin foil so you don't have as much cleanup. And then raise the jalapeno poppers up off the cookie sheet onto like a cooling rack. That way the excess grease drips down and the poppers are just delicious. Super good. Our chalk ball, we need to know if it's being held. By default, it is not. Over here, if it contains everything and it's a right click, then held equals true. Looking for the right mouse to get released, so m_held would equal false. If enabled and held, not move to, but set position e.x, e.y. Okay. I just want to see how this works. Do it tidy and debug. Let's see if the ball gets dragged around at all. We may change a little bit about it, but it just sort of moves around as expected. We'll make it better in a minute. Want to make sure the mouse handlers and the flag status are all correct. Okay. ChalkBall. ChalkBall should know about input. It will probably also need time eventually. Not quite yet, but it will. Okay, we have an ordering problem somewhere. Put input and time down here at the bottom. Okay, contains. We do not have a repeat handler. Okay, delete that one. We will implement contains. Float x, float y. Okay. We apply all of our transforms to our screen x, screen y. All right. Then we measure the distance, basically. From our own position. So we take x1 equals rectangle.x ry, and then float distance squared equals, oh, that's weird, x1 minus x naught y dx times dx plus dy times dy. Float radius squared equals rectangle dot width divided by 2 is the radius. Then we will square that, right? If distance squared is less than our radius squared, actually just return that, right? There we go. Okay. And hopefully the clamping works and the mouse events work. Okay, so there's the ball. And if I click around, nothing happens. If I click on it, nothing happens. Darn it. Well, shoot. Oh, the right click. Okay, so right clicking around. Okay, not a thing. Picked up chalkball. Dropped chalkball. We only check contains here. Chalkball contains r.w over 2. The center of the ball. X1, Y1. The click. Screen X. Screen Y. Oh, no. Whoa, 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 whoa. Okay, I know what's going on, I think. We're taking screen space into account twice. X1 equals 0. The center of our thing where we draw is considered locally to be 0. So if we took r.x and r.y, that's taking into account world transform. So try that. Just see what we get. If we put this all into local space, okay. It's checking. That the difference between where the center of the ball is and where the click is like 9 pixels in one axis and 1 pixel in the other. That's way less than radius. So why did it not pick it up? If we are enabled and it's a right click, and if we contain this point, okay, fine. Distance squared radius squared. Okay. $28 squared, that seems high. $200 squared. It's 400. 30 squared would be 900. Okay, so maybe that's fine. That's fine. Okay. Get that distance squared. Oh, right there. So we have to be off by about the size of the ball. So when we pick it up, held equals true, set position, e dot x, e dot y. X, X, Y, Y. Target plus, where did our R go? I deleted the rectangle. Perhaps because of the centering. Okay. Okay. Click over here. Click over here. Oh, we briefly had it. Oh, I think y has to be subtracted. Adjust for the size of the ball and the fact that our axes are all upside down. Okay. Okay, what if we do 2, 2. Okay. Oh, that looked better. So if we click near, it shouldn't pick it up. Unless we're very near. That was close enough, I guess. We could shrink the radius a teeny tiny bit to make sure that it's not quite as sensitive. Our target radius. Radius times radius. Press release move. Okay. There it goes. Now it follows the mouse very tightly and does not interact with the letters. And we can drag the mouse anywhere outside the bounds and it's fine. Woo! Awesome. Okay, so that part's done. It's all reasonably readable. Drop the chalk ball. Just fine. Pick up the chalk ball. Okay, so instead of setting our position, we're going to instead set a target. Num num. Now I should go to journal. All doesn't track mouse, but follows it. That's the next step. So let's save our work. Actually, let's save this work. Then we'll make it follow. Then we'll give it a velocity. It'll be great. Shouldn't get quite so much printing to the screen either. Okay. All right, right click. Checkball, chalkball. So this is happening somewhere else. Right there. So this is all good. Chalkball can now be picked up and dropped with right click. Okay. Oops. Chalkball can be picked up and dragged around the ChalkBoard. Okay. So now we need to track the mouse. There are a couple of options for that. It will always lag the mouse, basically. Because that will feel smoother. We also kind of want a maximum velocity, so you can't just snap the mouse and let go. So it will only accelerate to a certain speed. Yeah, we just want to follow the mouse. Therefore, what do we want to do? I can keep track of target position. So let's go follow X, follow Y. Target X, target Y. Follow velocity on the X component, velocity on the Y component. I don't know what a max velocity would be. Do I use the same velocity? I do. So I can say, what was my last X position? What was my last Y position? And that's all the information we need. You get 0 velocity when you get placed. Handle mouse press. Nope. You get M underscore target X. Target Y. Mouse release. Mouse X equals X. So its current position becomes its last position. So it always starts on a mouse press at velocity 0. Mouse release. We're going to come back to that. This thing gets this. Okay. Now, the important thing here is if M underscore held, we're going to do one thing. Else fake physics follow mouse. Okay. We want the vector from our current position if enabled. So we don't want to do any processing if we're not enabled. Short that right out. Class rectangular R equals this is our current X, Y, and we have our target XY. Whether we're doing physics or not, we're still checking these things. We want to know our target XY need to be clicked just like this. Only when we set the target XY. Y with target Y. Mouse move. Be clean. Okay. And then update. Float velocity on the X component equals current position minus last position. Our current velocity on the y-axis. velocity magnitude squared. We don't want to use any square roots if we don't have to, so we're going to take Vx times Vx plus Vy times Vy. Want the, that's velocity, so maybe velocity x, velocity y. Because we also have the vector from where we are to where we need to be. Vector is equal to x. Now we want to end up at m underscore target x and y. So that tells us our direction of travel. So here's the direction we're moving. Here's the direction we want to go. Let me think. I always want to move along this vector. We're going to cheat. Move by, let's see here. Let's take this. I want it to be smooth. Hey, Elpsy Kangaroo. How's it going? So far, we're doing pretty good, pretty good. How are you doing? What's new? We'll do a couple of things. Our V magnitude squared, Vx, our vector to go along the x-axis. If it's small, we just move to target X, target Y. I just got back. My wife wanted to take a walk. Haha. No, it's good. Taking a walk is great. Get the blood flowing. Have a nice chit chat with your wife. Always good. It's encouraged. It's probably even healthy. It's starting to get a little bit cold around here for much walking. Like, I don't mind the cold at this point, but it's a little bit cold for my wife to want to walk much. I want it to accelerate. So I do need to clamp. X, Y. If we have snapped to, then m underscore last x just equals where we are. We're going to snap to our location and lose all velocity. I think over here it's just the right temperature, to be honest. Well, whereas over here, I'm over on the, I'm on the west, not the west coast, but near the west coast of the United States. What's the idea for this update function? Well, let me show you. I don't think it's broken right now, so let's run it. So we've got this little purple chalk drawing of a ball, and if we right-click it, we can drag it around, right? I don't want it to track the mouse, I want it to follow the mouse. So if I move the mouse quick, I want it to accelerate and snap to where the mouse is over time. I don't want it to be herky-jerky like that. So we're writing a little function that'll calculate where we want it to be and where it needs to end up. So that's this function. We have the velocity of our ball given the current frame and the last frame. Although this is not scaled by time yet, we'll get around to that. Here's the direction to move to follow the mouse position, this target X, target Y. And then here's the, we can normalize this, direction vector if we want, and then maintain or increase our our speed based on our current speed. Not sure. There's a lot of different things we could do. Same. Oh, easing functions. Yeah, no. We're not using easing functions. We're going to be faking some physics later on. When you release the mouse, it's going to preserve the velocity and apply some gravity or something. It's just going to fall and bounce. But while you have the mouse on it, it's got to follow the mouse. I can't decide. So if we get real close, whatever that means, although I guess maybe anything less than 2 or 4 pixels or something, 4 pixels, 2 pixels, it just snaps to it and kills all the velocity. So moving towards direction, current velocity, So if velocity magnitude squared if they're moving too fast, they may never get close. It might overshoot. I haven't done one of these in a little while. It's been a while. Velocity magnitude squared. So we want to accelerate. So if our velocity is 0, then we add this component. If we suddenly change directions, we want to add this component by some amount, and then we want to clamp at our maximum velocity. Take vel x. This still doesn't take into account in time. Divided by time delta time. Vx vy. So vel x plus equals our vector of travel x times some acceleration factor, basically. Who knows what it is? Velocity y. Yeah, I'm not sure. I'm not thinking clearly. We don't want the change in magnitude to be very high. So let's do this. Let's do this. Float Vmag squared Vx Vy times Vy. If V magnitude squared is greater than some number, right? Maybe 100 pixels per second. And Vx equals V magnitude squared so we normalize and multiply by our clamped acceleration, which maybe is 10, I don't know. clamp, effect, of direction. Basically. Oh, this is squared, so maybe bigger is better. That's fine. If it's slow, we'll at least be able to see what's going on. Okay. So if we are close, we halt. Oops. We'll kill it. Otherwise, velocity x plus equals vx vy. We need a maximum velocity magnitude squared. This one doesn't matter. Oops. Velocity magnitude squared is greater than 10 pixels per second. That's not very fast either. 250? We won't accelerate very fast, but whatever. Vel x equals velocity of x normalized by velocity magnitude squared. Oh. We do need the actual square roots of things for when we scale. Okay, fine. Square root. It's fine. This is not going to be our biggest performance component, taking a couple of square roots. Times maybe 25. We're just picking numbers at this point. 25 pixels per second. Yeah, maybe it's 100. I don't know. We'll play with it later. Okay, scale the x, we scale the y, move by, oh. Set position to where we are. So x0 plus velocity of x, y0 plus velocity of y. That should force it to clamp to the screen until we release it, then it does nothing. We don't want to jump very far. We may also just oscillate over the top of it. Unused variable. Yep, that's fair. Well, let's just see what we get. It may not be great. Oh, we should multiply by delta time. Oops, that's going to be really bad. Oops. I want it to lag a little bit more, so we need less acceleration. Okay, so first of all, velocity x, velocity y. times 10 times delta time. Snap and kill momentum. Velocity, magnitude. We may be multiplying by time too much now. We're taking this velocity, which was already scaled by time, right? Take our distance divided by time. We're taking this vector, which is basically the desired delta V. That's not time scaled. Then we add that offset. Times delta time. Just taking the velocity, which we calculated in time, we have to add a distance in time. Then we can scale it and rescale it. Okay, let's try that. Maybe 10 and 100 are still too big of numbers. Maybe also my frame rate's just too high. Maybe updating fast enough to keep up with the mouse. If we put enough lag in, like if we change how fast it can accelerate and its maximum velocity, then we should be fine. Okay. It is trying to track. Now that we've added time components to it, it's very slow. But it is tracking the mouse, kind of. Let's make that faster. That's it. Crash, it's fine. So we're going to say velocity is greater than 500 pixels. And we're going to accelerate 25 max. That'll be 5 times faster. Acceleration will be 2.5 times faster. We'll see what it looks like. Okay. Whoa. Oh, as long as we were close, it tracked. So if we click. Oh, that's. As long as we don't move very fast, a couple pixels per frame, it'll track. Interesting. Okay, all right. So I guess let's try removing this whole clause right here. $1,000. Is that an acceleration problem? We could go for a full 100. Yeah, not exactly Newtonian physics, like a cartoonish version, I guess. Okay. I would argue the acceleration is a bit much, but the peak velocity is not there yet, so we have to go 50. Or maybe we want a more nonlinear acceleration. Okay. 3, 4, 5. See, that doesn't seem to be accelerating. Very much. Or what if we do this? What if we just say the change in velocity is always a constant? Our maximum velocity is not what I would expect. 3,000 is quite a lot, so let's see if we can get the acceleration to feel better or something. Whoa, insertion failed. Okay, fine. We're gonna do a full. Try tidy and debug. Hopefully that's enough to fix it. I contribute up to 3,000. Oh, wait, did I check this then? Okay. Right click. It's not accelerating. Oh. Oh. Maybe we're being too aggressive about clamping. Maybe we should ramp this way up. Oops. Full tiny. Oops. 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 Okay. I don't know. I'm starting to think maybe I should have implemented it as a spring constant kind of thing. Want it to feel a little bit springy. Okay. Okay. I think we need a bit more aggressive. Bit more aggressive. Like double, quadruple. You can still clamp it, but it should be a little more aggressive about the acceleration. Or we have a minimum amount of acceleration or amount of velocity. Or we're taking as velocity squared so that it has a higher acceleration and a more sudden deceleration at the end. Or we model the distance as an accelerate as a force. Force equals ma. 1/2. At squared. Oh, plus your current velocity. That's probably partly what we're doing. So we're not adding to our current velocity. This isn't far off. I don't want to do a more realistic physics and simulation, but we may have to make it respond the way we want to. That's not bad. All right. What if we did do what if we squared it? The further away we are, the more that contributes to the closer we get the, let's say Vx equals Vx squared. I was playing around trying to find the right look and feel without going full physics on us. We could do it as a spring constant. We could do it as a force mass acceleration, like an attractor, like gravity towards the point. I just want something that looks okay. That doesn't get too crazy. I would like to start dropping the ball and having it at least fly straight or maybe fall. Oops. Redecoration. You know, I was going to forget to do that. These velocities are going to have to be scaled with our screen size, so that's coming up shortly. Okay. Oh. No, it doesn't work at all. What the? $1,000. So going back to constant multiplier, just to see, because now the ball is not dragging anywhere. Not sure if I did something else that broke it. Okay. Let me just make this much bigger. 16,000. I don't know how much we're being limited by this factor. Step away for bits, still working on doodads. Oh yes, yep. We're just trying to make the click and drag of the chalk ball, try to make it feel a little better. And we'll try to preserve some velocity and apply some gravity and see what it does. So here we go. So the idea is you can drop it and it'll fall straight down, or if you give it some momentum and let it go, it'll toss the ball. Let it bounce off the walls and things. So how fast does it go? I'm not sure this term is doing anything. Or this term, rather. I feel like I'm change in velocity. Doesn't feel like it's working the way I would expect. It feels like it accelerates some. That didn't feel too bad. Maybe it's just all these terms then. These two terms, x. And clamp on 2000. Let me add our velocity, set our position. Oh. Our, oh, that's probably okay. Our velocity is scaled by time. The amount we want to add to the velocity is scaled by time. And then we add the velocity. Okay, we're probably close enough on that one. We'll probably start doing gravity and preservation of velocity. And not real gravity, it'll be fake gravity, very fake gravity. Okay. Well, that feels snappier. Whoop, whoop. Launch the ball. Bonk. Okay, probably good with that. Journal. Ball doesn't track the mouse, but follows it. Gravity, velocity, and damping physics. Chalk ball follows mouse with some delay. not scale to screen size. Which we should probably just check that before we check this in, huh? Okay, so let's go to airplane Doodad. Where we're doing not our airplane. Doodad chalkball. Here we are. We have 3 constants. Static, or no, not static, just call it float. Excel factor equals renderer scale 16. This is our Excel factor. And we have our max Excel. Which will be 2000. Oh. No, we don't even have a max velocity anymore. So that should scale the screen size. All right. So it should feel reasonably similar on both screens, on screen sizes. So let me go to play. So that's what it looks like on a big screen. And then let's make it small screen. Oh, that offset is wrong. And wrong. Yep, there's a couple things wrong. All right, quick restroom break. Just a minute. Okay, let's see. Part of me, well, let's see. We have some offset issues with our screen size. We are scaling the width and height, so it is rendering the correct size. We set our rectangle, we set our center, so that should be the same when scaled. Mouse release contains. Handle mouse movement. Not sure why it's working differently at a different screen size. I think I was taking everything into account. That's what I thought. But at small size, it's off. And it's not tracking correctly. That's not the center of the mouse. Now that still feels about right, but why is the position off? Why is it the bottom right-hand corner that it's tracking? Set position. Center. It's almost like this line isn't doing its job properly. Oh. Oh. Okay, let's see. W. I know why. H. Now this width and height will be scaled and then, so there we go. That fixes that, I'll bet. Yikes. Okay. So different screen sizes, it should work the same. That's the main issue. Okay, easy peasy. There it is. That's the right place. put it there. Okay. All right, so that's working. Now we can save that. Now it's worth preserving. Okay, it says ball now tracks or follows mouse position. Okay, so we're going to add gravity, velocity, and damping in ChalkBoard. So, follow the mouse, clamp, fake physics. Fake physics. If we are not being held. Force equals mass times acceleration. Acceleration of gravity. We don't have a mass, so it doesn't matter. And gravity is in pixels, so it doesn't really matter. So we're going to take force equals mass times acceleration. Our acceleration is just down, so it's y plus. So const float gravity equals plus 100 pixels per second squared. Then float in this velocity. Velocity of x plus equals gravity times time. Then, so that should move down. It's just this. So we've already factored in time here and there. So we'll pick up velocity until it hits the bottom or hits a wall. Then it'll just stop, in theory, since it should clamp. Which is not right. We want it to bounce, but that's besides the point. So to start with, we're going to pick it up and drop it. Bonk. All it's doing is dropping. So it's not preserving that previous velocity at all. When we release, velocity y, last x, last y. I see. This has to happen after this. We never have a velocity. Oh, we're going to blow things up a little bit. Oops. It may actually accelerate and decelerate. These accelerations and velocities may be too huge now. That's just me being silly there. I thought the behavior was a little bit wonky, but oof. Okay. Well, not too bad, actually. Did I not build? Oh. Also that. Set position also kills velocity. We want to clamp, but not, let's see here. We need a different function call. Not move a set position. We are going to call it update position. Where is set position? There, this one. Update position, move to, then set position. Just calls update position. And then kills momentum. Which means our update doesn't call set position, it calls update position. Gravity and some basic velocity stuff until it hits a wall. Hopefully. Okay, one more try. Oh. Well, that's awkward. That may be because of this and this being huge. We may need a maximum velocity as well. Why it's in that corner to start, I don't know. Unless it's trying to update. Huh. It is clamping those corners hard. If it's held. Vx, v magnitude. It's greater than our maximum acceleration, which in this case is 10. Axle factor 1. Blah, blah. not going to get any gravity testing if we can't get the dragging right. Oops. Yeah, a couple of issues there. Starting to think maybe I should have just gone with the spring simulation or something. Oh, I don't like it when it's in that position. Let's delete the fake physics. Let's see how much of this is related to that issue. Our gravity may just be too big. 100 pixels per second squared? I don't think it should be that bad. Is the issue in the holding or in the... Well, it's probably in the holding. That's... Oh, well, that's now in the correct position to start, and without gravity happening. Oh, interesting. Acceleration factor, V magnitude, clamping, maximum acceleration. Velocity. Update position. Update position. Clamp X, Y, move to. Oh, I'm not sure what's going on anymore. Let's see. I would maybe expect some jitter if our velocity was very small. If the V magnitude is less than 2, V mag equals 0. Or if it's small, then V x equals 0, V y equals 0. Let's see, x velocity y. Clamp velocity magnitude. Is the maximum acceleration just too big? Max accel is time scaled. Nope, whoa, come back. Acceleration factor 1, yeah, not worry about that. That just makes it snappier or not. Maybe I shouldn't have tried to do fake physics. Maybe I should have taken it more seriously as an actual physics piece. What even is it doing? The last time we were somewhere, here's where we are now. Here's where we were last time. We took a measurement. 0. Let's go to the Excel factor. This is the vector from our current position to the mouse. We find out how big that is, and if it's too big, we clamp it. Oh. Let's do all the DT stuff here and not here. Now it's not doing anything. When we multiply by delta time, we're basically saying we want to move this far on the x-axis in 1 second. Our max, and this is actually a delta v. This is how far we want to go. If the distance we want to go is greater than some amount, we clamp it. Do I redo this all with physics? Real physics, more real physics. Maximum amount of velocity to add in a second. Let's just call that 10. Our current velocity is the last position from our current position. So if we're moving positive, velocity x, current position minus the last position. Okay. That's our velocity, so it has to be scaled by time. If we're holding a mouse, this is the direction we want to go. The vector along the x-axis to our target. Here's how far away we are from the target. If we are a long ways away, then we just scale it down. When we divide by v mag, we're basically saying make this the the unit vector. Then we multiply by maximum acceleration, so that's the highest we can ever accelerate. Anything greater than that gets clamped down. If our magnitude is very, very small, then we just don't do anything. Otherwise, we add to our current velocity this much stuff, and then we update our position from where we are plus our velocity. This equals, and this Vx, Vy is pixels per second. Max excel is, call it pixels per second, plus equals this many pixels per second times dt. Not sure what I've done. It's all slightly Newtonian, but I'm not dealing with mass and forces. They're sort of implied based on the distance from the mouse. Huh. Oh, whoa. Nope. What's causing that? Ten. Well, let's see here. Update position. X, Y. Then we clamp for new values and move to set position, but it kills momentum or kills velocity. There is none. Update. Unclamp our velocity. Maybe we're doing something goofy there. Yes, another unused. It's fine. Yeah, we may have to revisit this. I'm Probably just not seeing something very obvious due to the end of the stream, streamer brain. Because I've built similar systems before and not struggled too much. Curious. What if you scale up to big screen? Maybe there's something missing about the scaling we're doing. Big screen, which you probably can't tell, but it is bigger. It's kind of trying. All right, well, I have a couple of ideas. I just didn't want to do them. Okay, we'll probably do them tomorrow then. All right. Probably got to call it there. When adding gravity, etc., found some issues with the underlying stuff. Need to completely revisit mouse following. Either simplify more, just vector to mouse, and some velocity stuff, or do spring simulation. We'll do that tomorrow. Oh, no, we won't do it tomorrow. Tomorrow is compiler day. All right, well, tomorrow's compiler day, so we will see you tomorrow for compiler day. Mouse follow, top ball is broken. Okay. Yes, you have a wonderful evening. I'm gonna ponder deeply on that. And then, yeah, we'll see you tomorrow for compilers. Have a good evening. Yes, thank you, JTL. You too. Bye-bye.